Welcome to the sixth slide session of Principles of Industrial Engineering. So today we will be discussing on scheduling, which is used under the production planning control uh, for determining uh, when particular type of operation will be carried out and where it will be carried out. So we'll understand the scheduling, different techniques which are used, advantages related, and under what conditions it was used, like which method of scheduling should be used. So let's start with the question. Objective of material requirement planning is which reduction in lead time and delivery of the product, improvement in the capacity planning, expediting of the process, all of the above. So there are three big objectives which are realized through material requirement planning. Firstly, it helps in reducing the inventory. Secondly, it reduces the delays in production or reduces the lead time delivery or the lead time related with the deliveries of the item to the customers. And finally, it also increases the efficiency of the production system as a whole, which means it helps to increase the productivity. So according to these options, uh, so the correct option is reduction in lead time in delivery of product. So we'll just understand. Okay, so I'll write a few points regarding this. Three objectives of MRP. Reduces the delays in production or reduces the lead time delivery. And the third one is increases the efficiency of the production system as a whole. So the correct option is a reduction in lead time in delivery of the product. Okay. So also I want to just there's regarding that reducing the inventory, whenever whatever items are needed, arrangements are made for the procurement so that it is not required to keep much of those items in inventory, and this in turn will help in reducing the inventory. Regarding the second objective, it reduces the delays or it reduces the lead time for delivery. Since we have already identified the kind of item, quantity of item, and when these items are needed, so this in turn will be leading to the availability of the input demand items or items needed for smooth production. So the production will be going on smoothly and this will avoid any kind of delay due to the lack of material. Thirdly, it increases the efficiency of the production system as a whole, which means MRP is basically the coordination among departments, work centers, which helps in smooth uninterrupted flow of the material during the production. And when it happens, we find out the output of the production system is enhanced and this helps in increasing the efficiency of the production system. Okay, so the next question. The correct sequence of operations in production planning and control is which of the following? So the correct sequence is routing, scheduling, dispatching and follow-up. So we will just discuss briefly about all the methods. First is routing. Routing. So it is about the flow of the work or the material in course of production. So this means that what will be the different stages through which it will be passing. Suppose example stage A, B, C, D are the different stages through which it will be passing. So what will be the different parts followed will depend upon the layout of the facilities. Next is scheduling. Sorry. Scheduling is it will be the time when particular work will be started and finished. So it will also tell us the sequence in which the operations will be done so that it will be completed on time. Next is dispatching. So in production planning and control, we had two things, production planning and control. So there is also an execution action phase. Here in action phase, the commencement of the production takes place. Of the production takes place. And for this, whatever the relevant orders are there to the shop floor to start the production, that is given through dispatching. And for this, whatever the relevant orders are there to the shop floor to start the production, that is given through dispatching. Okay, next is follow-up or so in follow-up we will have the expediting. Expediting is also known as follow-up. Here we will be having the close observation of the execution. Close observation of the execution. So it involves the follow-up to see what is the current status. It involves the follow-up to see what is the current status at any time. At any time. And this will help us in identifying the bottleneck in the production system. If you can estimate the bottleneck in the production system, suitable efforts can be made to avoid or reduce such kind of bottleneck. So these were the sequence of operation followed in production planning and control. So the next question is, routing contains information on the following. Which of the options? Operations, capacity of work center, sequence of operations, all of the above. So, routing is about the sequence. Routing. Yeah, correct. D is the correct option. So routing is about the sequence or the path that material will follow in course of production. Course of production from its initial raw stage to the final finished production, finished product stage. So in routing, we have to identify the most efficient and effective path which will be followed by the raw material in course of its production up to the final finished stage. So this is why this is done. This is done so that it can be manufactured in a minimum possible time and in a most economical manner. So this can then it can be made available to the customers at a low cost. It will also be identifying the kind of the work centers, the kind of the machines or departments or sections through which the material will be moved in course of production under the routing. So in the department work centers, the machines are identified through which the material will be mostly passed in course of the production. So this overall, this method or this process will be identifying the different operations to be performed, the different sequence that will be followed. Okay, so the next question is, determination of sequence of operations to be performed and allocation of facility where these operations are to be performed is, okay, we just discussed sequence of sequence performed in is in routing. Identifying the different operations to be performed and the different sequences to be followed. About master scheduling, aggregate planning, we will be discussing on the further questions. Okay, so the next question is, loading may be defined as which of the following? defined, loading is about the determination or identification of the assignment of jobs to a specific machine or to work center or to a facility. Okay, so depending, uh, so correct option is D, loading is about the determination or identification of the assignment of jobs to specific machine or to a work center or facility. Center or facility. So depending upon the kind of production system, jobs can be assigned to the individual machines or to a whole work center or to entire plant or facility. So someone has to like suppose we have to decide that some 1,000 cars will be made in particular facility, or some units of particular type of the jobs are to be made to a particular work center. So this is done by this loading. The next question is, according to the earliest due date rule, the jobs are processed in sequence of which of the following? Okay, so there are various methods: earliest due date method, short processing time method, and critical ratio, critical ratio rule, and slack time remaining rule. So these are the sequencing methods. So this is basically a single machine sequencing. So we will just understand what is a single machine sequencing. So in sequencing, our aim is to find the order in which different jobs are to be processed or on different machines so that idle time is minimized. So according to this, in single machine sequencing, we have various methods. Okay, so this is the EDD method, earliest due date method. So suppose there are jobs given, processing time is given, and due dates are given. So we will also discuss a numerical on this question. Suppose randomly, if I am giving you 1, 2, 3, 4, these are the jobs, processing time is let's say 6, 9, 12, 7, due dates are 10, 6, 16, 20 and 30. So this is I'm explaining through an example so that it will be easy. So with this, now first you will make a column jobs. This is the processing time. This is the due date time. Now this is the next will be the your job flow time. Flow time, and this will be your tardiness. Now what is tardiness? Tardiness is the delay. It is the amount of time by which a job is delayed beyond the due date. Okay. So now first we have to arrange the jobs in order of their earliest due date. Now here in this question, it is already in your arranged in your earliest due dates. Okay. So we'll write 6, 9, sorry 10, 9, 7. This is the job number. Now the due dates are 10, 16, 20, 30. I just took the values. This column is already arranged. So whatever your data is there, you have to arrange it in the form of their increasing due dates. Now you have to add the flow time. Okay, so here 0 plus 6 is equal to 6. 6, just keep on adding this. Okay, 6 plus 10 is equal to 16. Then 16 plus 9 is equal to 25. 25 plus 7 is equal to 32. Okay, so total is flow time is 32. Now see, now the job flow time is lesser than the due date time. So there is no delay. So it is 0. Again the job flow time is equal to the flow time to the due date time. So again there is no delay, that is 0. Now again the job flow time here is greater than the due date time. Since job flow time is greater than due date time, 25 greater than 20, so there is a delay of 5 days. So the tardiness is 5. Again here, next their job flow time 32 greater than 30. Job flow time is greater than the due date time by 2 days. The tardiness is 7. So here the total tardiness is equal to 2 plus 5, 7. If someone asks number of tardy jobs, see these are some of the gate questions, so you should be clear about what is asked. Again, if someone asks what is the average tardiness, it will be 7 by number of jobs, it will 7 by 4, whatever will be the answer. Then maximum tardiness, what is the maximum delay? That is 5 is the maximum delay. Answer is 5. And if someone asks what is the total flow time, the total flow time is equal to 6 plus 16 plus 25 plus 32 is equal to 70. So this is the total flow time. This, when you add all this will be the total flow time. This is 79. Okay. So from this earliest due date rule, we find out the total tardiness. So now according to the question, the jobs are processed in sequence of increasing order of their due date. The correct option is this. Highest priority is given to the job whose due date is earliest. Sequencing is based on the earliest due date. Also, one more point is, this is very important, EDD rule minimizes the total tardiness. Okay, so I hope you are clear for this question, and you can solve any questions on earliest due date. So the next question is, Okay, so the next question is, uh, for the person who joined now, I'll just say you that we are solving questions on earliest due date rule. You can just see it through the video next. Moving on to the next question. Sequencing is the subset of which of the following? Okay. So sequencing, just as we saw in the previous example, it is basically determining the order of the sequence of processing the jobs at a facility, plant or machine. Okay. Yes. Correct answer is C. So sequencing is determining the order or sequence of processing of jobs at a facility or plant or machine. Now, now we know that sequencing is a part of the scheduling. So, as we know that in scheduling, we identify that when the job will be done. That is, in scheduling, we identify when the job will be done. That is, start and end dates are identified and where it will be done. But however, under scheduling, which jobs will be taken up first and which job will be taken up second is also identified. So this is the important. Which sorry, which jobs will be taken up first and which job will be taken up second is identified. This is the major difference between scheduling and sequencing. Okay, so the next question. If a job is completed before the due date, then its critical ratio must be greater than 1, lesser than 1, equal to 1, can be of any value. So critical ratio all is like the ratio of due date from today divided by the processing time. This is critical ratio. So what is critical ratio? Critical ratio CR due date by processing time. Now here in the critical ratio rule, we sequence the jobs in order of increasing critical ratio. Now if a critical ratio is greater than 1, it indicates the job is being done ahead of the due date. Critical ratio greater than 1, critical ratio less than 1, critical ratio equal to 1. So greater than 1, job is being done ahead of due date. If it is less than 1, job is being done behind the due date. That is, it is late. This is early. And equal to 1 means job will be done exactly on time. Okay. So here, when it is completed before the due date, that means its critical ratio must be greater than 1. Correct answer. This is the okay. So moving on to the next question. Shortest processing time rule offers which of the following? Okay. The correct option is shortest processing time means, as per the name, it is topmost priority is given to the job which is having the minimum processing time. So for this we will do a short question where you will be clear. Same question we will take the previous example. The question is jobs correct answer minimum the mean job flow time. The topmost priority is given to the job which is having the minimum processing time. Now the question is same as the previous one, jobs processing time and due date. Now jobs are 1, 2, 3, 4. The processing time is 6, 10, 9, 7, 10, 16, 20, 30. Now we have to use the SPT rule for this. So according to the SPT rule, now we will make the table again. Jobs processing time, due date time, this is the flow time or completion time, and this is the tardiness or the delay. Now we will arrange the jobs in increasing order of their processing time. 1, the smallest one is 6, so it will be 6, 10. Next is 7, next is 9, next is 10. 7 is for the job 4, 9 is for job 3, and 10 is for job 2. The flow time is due date time is 10, 30, 20, 16. The flow time is here 0 plus 6 is equal to 6, 6 plus 7, we are taking care of the processing time. 6 plus 7 is equal to 13, 13 plus 9 is equal to 22, 22 plus 10 is equal to 32. Now we'll find out the tardiness for each jobs. For the job 1, flow time is 6, due date time is 10, it is ahead. So here the tardiness is 0. Again the flow time 6 less than 10. Next is the flow time 13, due date time is 30. So again it is ahead, the tardiness is 0. 13 less than 30. Next is flow time is 22, due date time is 20. So this one 22 flow time greater than due date time, so tardiness is 2. Next is 32 flow time and due date is 16. It is much ahead, flow time 16, so tardiness is 16. Now here for this question the processing time is 1, 4. The arrangement is 1, 4, 3, 2, and the total tardiness you can get 18. Flow time you can, as like the previous question, you can find out all the information according to the questions asked. Okay, so next question, moving on to the next question. Critical ratio in the scheduling is, okay, ratio. Now just see the options. Okay, the options are different as compared to the previous question. Here it is the ratio of due date and processing time, ratio of due date and make span time. What is make span time? Make span time is the minimum time required for a machine to complete a set of jobs. So like a question in which we solved the numerical. So here the make span time is equal to 6 plus 10 plus 9 plus 7. Just add up all the processing time is equal to 32. This is the make span time. If we go to the previous question which we just solved according to the SPT rule, I'll just write down everything. Here total tardiness is equal to 2 plus 16 is equal to 18. Number of tardy jobs is equal to 2. Average tardiness, total tardiness by total number of jobs will be 18 by 4. 4, 4.5. Next, here maximum tardiness, 16. Make span time, here is, just add up the 6 plus 7 plus 9 plus 10, 32. Total flow time is 6 plus 13 plus 22 plus 32 is equal to 73. So now we solve two questions in both methods, short processing time and earliest due date time, and you will see that the tardiness is different in both cases. In short processing time the tardiness is 18 and in the earliest due date time the tardiness was 7. So you can see why the same question is solved in both the methods, to find out the difference which gives in both the methods. Okay, so the critical ratio is the ratio of due date and processing time. Okay. Due date by processing time. Now, next we are clear with all the terminologies. Due date, job flow, make span we just learned, processing time, due date, processing time, due date. Okay, the next question. Root sheet. What is a root sheet? Root sheet gives the information about which of the following. So the root sheet gives information about the kind of the production order which is under process. It is for a specific production order which is being processed. Root sheet gives information about the specific production order which is being processed to give the desired output with the due date. It also gives the information about the order number which is in process. It also says the number of items to be produced and the machine to be used for operations, and list of all operations to be performed. Finally, it also gives what will be the sequence of operations that will be done in course of the production. So basing on all these options, the correct options are 1, 3, 4. Order number identification, name of machine and list of operations, sequence of operations. It does not say about the process parameters of different manufacturing process. Okay. So the next question. Master production schedule generally involves which of the following? Information of inventory, forecasting of demand, availability and capacity of resources, all of these. Okay, so in master production schedule, we identify the entire required quantity of the item to be manufactured to satisfy the demand. So according to the quantity, again we decide whatever input materials or demand dependent items are required in form of raw material or semi-finished product when these items are required. Thus, we identify the quantity of raw material, items needed, and the time when these materials are needed for smooth production. So that the production schedule requirement um, can be satisfied. So main functions of the master production schedule is it helps to translate the plan into specific end items, evaluate the alternative schedule so that the best production schedule is affected for implicated for maximum the productivity. It also provides the input for the capacity requirement and the capacity planning. It also helps in effective utilization of the capacity. So basing on all this, the correct option is all of these. Information of inventory we need to have. It involves forecasting of demand. How forecasting of demand with this we will be. So it takes into account the items, the quantity of items to be produced for satisfying the demand of the customers. So at the end we need all those items to be produced so that the demand of the customer is satisfied, and for this inputs can be taken for two sources. One is like based on the customer's order and other is the expected demand. Input is from two sources. Customer's order, another is the expected demand. Sale forecast, we can say this. Though this is the forecasting of demand. So based on these two inputs, quantitative items will be produced so that demand in future can be satisfied for the master production schedule. Now whatever items are to be produced will be dictating the kind of input material to be used. Okay, so this whatever items to be produced will be giving information about the kind of the input material to be used for smooth production. So we need to have our information of the inventory, like we identify the raw quantity of raw material or items needed and the time when these materials are needed so that we can satisfy the demand. Okay, so the next question. A horizontal bar chart that shows project tasks against a calendar is called PERT chart, pie chart, Gantt chart, line chart. The correct option is Gantt chart. It indicates the load which has been given to particular kind of machine, or how long a particular job will be done on a particular machine, or how long a particular worker will be doing a particular kind of job, what are the different activities which will be performed by a particular machine or particular worker for a certain time. Now, what is a Gantt chart? I'll just show you a small example for a Gantt chart. Suppose this is the x-axis, sorry, there was some problem, y-axis. Now here we can say the job number, and here we can have the time. Okay, suppose that's 1 2 3 4 5 6 7, and here we can mention the jobs, job 1, job 2, job 3, and so on. So it's a simple chart only where we indicate the time in x-axis. X-axis is time, y-axis, this can be in days, hours or months, whatever, and y-axis we mention the jobs. We here have given it like job 1 2 3 4. Thus job or number of subjects or operations to be performed, a worker who will be doing the jobs, all these can be given in y-axis. So thus it indicates the load, indicates the load which has been given to particular kind of the machine, how long a particular job will be done, and rest all, and how long a particular worker will be doing a particular kind of job, and all such type of scenarios. So the next question is, different jobs are to be processed on a machine in a specific order is termed as, we already discussed, this is sequencing. determining the order or the sequence of processing of jobs at a facility, plant or machine. Scheduling we already know, master schedule planning also we already know. Next is aggregate planning, which we'll be discussing on the further question. The correct option is sequence. The next question, for the critical ratio rule, the job is said to be ahead of schedule when? We already discussed critical ratio greater than 1, critical ratio less than 1, critical ratio equal to 1. So in the ratio less than 1, it indicates greater than 1 job is being ahead. Job is being done ahead of the due date. It is behind. Job is being done behind the due date. Job is on time, equal to 1. So the next question, the jobs which are completed after due date, which is termed as which? Tardiness job. We already saw in so many questions. The correct option is tardiness job. Tardiness is amount, tardiness means amount of time by which a job is delayed beyond the due date. Next question. 5 jobs are to be processed on a machine. So using the shortest processing time, the average tardiness of the 5 jobs will be, we have to find out using the SPT rule. SPT rule. So here first we will arrange the jobs in order of their increasing processing time. We will make the columns jobs, processing time, this is in days, due date, this is again in days, job flow time, this is in days, and we will make a tardiness column also, this is also in days. Okay, now the minimum processing time is 3. This is for job C. Next is 5. This is for job A. Next is 6. This is for job D. Next is 7, job B. And next is 8, job B. The due date for, I'll write the corresponding due date for the jobs. Now job flow time will add up. Job flow time 0 plus processing time for the first job 3. This will be 3 plus 3 plus 5. This will be 8. Next is 8 plus 6. This will be 14. 14 plus 7. This will be 21. 21 plus 8. This will be 29. Now the first one, job flow time is equal to processing time, tardiness is 0. Here if you can see, the critical ratio will be 1. Then the job flow time is again greater than the due date. The job flow time is less than equal to due date. Sorry, in this case the critical ratio is 1. Here the critical ratio is greater than 1. Okay, I'm sorry. Now the job flow time is less than equal to the due date time. So again the tardiness is 0. First job, for the job C, job flow time was less than the due date time, so the tardiness is again 0. And for job D, the job flow time is less than the due date time, again the tardiness is 0. For job E, the job flow time is greater than the due date time, here again the tardiness is 1. And for the job B, the job flow time is greater than the due date time, the tardiness is 19. Now here in this question we see that jobs E and B are delayed, so total tardiness is equal to 1 plus 19 is equal to 20. Average tardiness equal to 20 by 4 is 20 by 5, since total number of jobs is 5, is equal to 4. So the correct option, the average tardiness of 5 jobs is asked. The correct option is option B, 4. Any doubts? Okay. If there are no doubts, we'll move on to the next question. Can you please mute? the next question. So here one thing you will notice that in this case the critical ratio is equal to 1. According to the least critical ratio rule, the given 5 jobs are to be processed in a sequence. So till now we solved using the SPT rule, EDD rule. Now we will solve based on the least critical ratio rule. So here the jobs and processing time and due dates are given. Now we will find the critical ratio for each method. Critical ratio. Critical ratio for the first method is due date by processing time. This will be 20 by 8 is equal to 2.5. For the next job 2 is 12 by 4. The critical ratio, this is 3. For the next job it is 15 by 10. It is 1.5. For the next job is 56 divided by 16. This will be 3.5. For the next job is due date 4 divided by 2 is equal to 2. Now, according to the least critical ratio rule, jobs are processed according to the order of their increasing critical ratio. So the order will be three. The order will be 3, 5, 5, 1, 2 and 4. Corresponding critical ratio I will write below. For the 3 is 1.5. Then is next 2, 2.5, 3 and 3.5. So the correct option is 34125, which means 3, 4, 3, 5, 1, 2. This last option is the correct. Okay, so I hope this question is clear. So the next question is based on the least slack rule. This is again an interesting question. Now least slack rule, here we arrange according to the slack time. So I'll make a column here. slack time so slack time, this is for the first job A, the slack time is 10 minus 7 is equal to 3. The second job B, slack time is 14 minus 12 is equal to 2. The third one is 20 minus 4 is equal to 16. The next one is 25 minus 8 is equal to 17. Now, we will arrange according to the least slack rule, jobs are processed. Now, according to the least slack rule, jobs are processed according to the order of their increasing slack time. Now we will prepare the column again. First one is jobs. This is processing time. This is the due date. This is the job flow time. And this is the tardiness column. All are in days. Now the least slack time is for job B. So we will put the B job first. Next is job A. Next is job C. Next is job D. So accordingly we will fill the corresponding data for all. 12, 7, 4, 8 processing time. Due date time is 14, 10, 20, 25. Job flow time is, now for the job B, 0 plus 12 is equal to 12. For job A, 12 plus 7 is equal to 19. For job C, 19 plus 4 is equal to 23. For job D, 23 plus 8 is equal to 31. Now tardiness is for job B, the job flow time is less than the due date time. So tardiness is 0. Now for job A, job flow time is greater than the due date time. The tardiness is 9. For job C, job flow time is greater than the due date time. Tardiness is 3. For job D, job flow time is greater than the due date time. Tardiness is 6. So here jobs A, C, D are delayed. Total tardiness is equal to 9 plus 3 plus 6 is equal to 80. So the correct option is option D, 80. Okay, so moving on to the last question. The least slack time is measured by which of the following? We just discussed this question. This is flow time minus due date. Due date Due date minus processing time. Sorry, due date time minus processing time. So the correct option is due date minus processing time. Okay, so we reached the end of the questions. Any any doubts so far? Okay, so any doubts so far you can ask. So we discussed questions based on all the rules: least slack time, least critical ratio, earliest due date, short processing time, and this will really